All right, we're on 5/9's homework, and we are starting on number 4. So we are working on proportions and cross multiplying. So a couple basic problems to get you started on your homework. So we're going to multiply the diagonals, and they're going to be equal to each other. That property always holds true in a proportion. So cross multiplying here, we're going to get 48n. Cross multiplying here, we're going to get 80. And now we can go ahead and solve that. And so 48 gets divided on both sides. And 8 over 48 will give you a decimal, which you could write as a repeated decimal if you want to do it that way. You can see it's 1.6 repeated. We know that's 1 2/3, so you could write it as that mixed number, 1 2/3. But the best way, the way I would prefer that you write it, is as a simplified fraction, which is 5/3. Okay, now these problems also ask you to check your work. So how do we check it? So we're going back to the original, we're plugging in our answer, and we're making sure that it works. So we're putting 5 over 3 in for n, so that's being divided by 4, and it's got to equal 20 over 48. So I think the best way to do this is to go ahead and divide this, see what we get, divide this, see what we get, and make sure they're equal to each other. So we've got 5/3. We're going to divide that by 4. Now that's going to give us 5/12. On the other side, if we go ahead and simplify 20 over 48, that's also going to get us 5/12. It's possible, though, that you had 1.6 repeated as your number that you got because you did 80 divided by 48. And then you would take that, plug it in, and divide it by 4. And we get this, 0.416 repeated. And if we were on the other side and did 20 divided by 48, we should get the same thing, and we do. So 2 different ways to show it. This is a lot cleaner, a lot more precise than the repeated decimals and everything else, so that's why we prefer this. But both still can show you if you got the answer right or wrong, which is the whole point of the check. So number 5. Basically the same thing. Cross multiplying, so the diagonals, negative 28 times p, they get attached, and then 21 times 64, and we're going to divide. So p equals negative 48. And again, to check our work, we're going to go ahead and plug it in. You can either divide and make sure you get the same decimal. So negative 28 divided by 21, when you look at that, again, it's a repeated decimal. So as long as you get the same repeated decimal on both sides, that's fine. But I think it's better if you just leave it as a fraction. So we'll simplify it. Oops. So negative 28 over 21. Negative 4/3. So first let's write this out. Instead of p, we're going to plug in negative 48. So this left side is going to simplify to negative 4/3. And 64 over negative 48 will also simplify to negative 4/3, so our check works. So we know our answer is good. All right, next up is number 6. So now we're going to take these basic skills of cross multiplying and apply it now to some problems. So on a map of Spain, 3 centimeters represents 200 kilometers. So that's our important rate that we need to set up. So number 6, we're going to start with that. 3 centimeters equal 200 kilometers. Notice that I put the units there. It's really important because when we set up the other side, they need to match. And so once you get the hang of this, you really just set up your initial ratio here, and then all you have to do is take whatever information they give you and just place it in the right spot. Most likely what you're missing is going to be your x, and then you just go ahead and cross multiply. So for part A, it says Seville and Madrid are approximately 417 kilometers apart, how far would they be on the map? So how many centimeters on the map? Every 3 centimeters on the map is 200 kilometers. So if they are 417 kilometers, how far are they on the map? How many centimeters? So that's how you set that up. Now you just do your basic cross multiplying. So you're going to get 200x. Okay, and it doesn't matter which one you do first. I tend to do the one with the variable first, but it doesn't matter. And 3 times 417. 1251, we're going to divide by 200. And so x equals 6.255 centimeters. So that's how far apart they would be on the map. If in real life they are 417 kilometers apart, we might as well put the M there. Okay, part B. Barcelona and Madrid are 9.4 centimeters apart on the map. So let's start over. They told you 3 centimeters represents 200 kilometers. Okay, that's your important conversion rate. Now they're telling you, they're giving you something in centimeters. So they're telling you they are 9.4 centimeters apart on the map. How far are they in real life? Kilometers. Okay, so because I set these units up nicely, centimeters over kilometers, I just need to make sure I do the same thing on the other side and just figure out what did they give me. They gave me centimeters, put it up here, so I'm solving for kilometers. How far are they in real life? So cross multiply, 3 times x is 3x, and then 200 times 9.4. And finish it off by dividing by 3. So 626.6 repeated. And of course, we know 0.6 repeated is 2/3. So if you said 626 and 2/3, that's fine too. And these are kilometers. So how far are they apart in real life? Okay, next up is number 10. It says 2 numbers are in a ratio of 9 to 5, and one number is 76 greater than the other. What are the numbers? So they give you the initial ratio to set up. So it's 9 over 5. And so with our other information, we're going to set up a ratio that's equal to this, which means in proportion, so we can cross multiply. We know that this is the ratio. The larger of the two is 9/5 the size. So when we set up this side, the only information we have is that one is greater than one is 76 greater than the other, which would be the bigger one. So this one up here is going to be 76 bigger than this one. So anytime we have an unknown in these things, we just call it x. So I'm going to call this one x. We technically could call this one x. We can talk about that in a second. But what you would do now is say, if this is x, I don't know what it is, but I know the relationship between these two. This one's bigger, and it's exactly 76 bigger. So I take whatever x is, and I add 76. If you were going to set it up the other way, if you put x up top, since this one up top has to be 76 bigger, if you call this x, you would have to call this x minus 76, because it's 76 less on the bottom. But it's important that the bigger of the two lines up with the 9. Otherwise, we're not in correct proportion. Okay, so 9/5 equals x plus 76 over x. And now all you got to do is cross multiply. So I'm going to get 9x from this diagonal. When I go this way, you have to put this in parentheses. And we're going to distribute. So my next line is 5x plus, got to multiply, $380. So I'm going to minus 5x. So 4x equals 380. I'm going to divide by 4. And I get 95. Now, I haven't done anything incorrect. This is good so far. But I need to go back and answer the question. It says, what are the numbers? What are the numbers? There's 2 of them. So this could be the bigger number. This could be the smaller number. I need to go back and figure out, how did I set this up? So x is 95. That's this one. That would be the smaller of the 2. So one of the answers is 95. So if x is 95, the other one is the bigger one, and it's 76 more than. So I'm going to just take my 95 and add 76, and that gets me my other answer of 171. Okay, 11 and 12 down here at the bottom are giving us more practice of cross-multiplying when we have bigger expressions, as opposed to 4 and 5 where we just had a single variable. So let's run through these just real quick. Make sure we've got the skills needed to move on. So 4m minus 1 over 7. Go ahead and cross-multiply. Again, it doesn't matter which one you do first, but if I'm taking this times this, it's 2 times the quantity, 4m minus 1, so you got to put it in parentheses, and that's going to equal the other diagonal, which is 7 times m plus 2. First step would be to distribute, so 2 times 4m is 8m, and then the 2 times the negative 1 is negative 2. 7 times m, 7m. 7 times 2 is 14. Okay, m's on both sides, so we want to get rid of the smaller of the two. So we have a 1m minus 2 equals 14. Go ahead and add 2. And m equals 16. No check required on these, so we're done. And number 12. Doesn't matter which way we go. So 5 times this, I'm going to do first. 12 times 2p minus 3. First step, distribute. 12 times negative 3. Right, now we have p's on both sides. Get rid of the smaller one. So 24 minus 15 is 9. Now we want to get p by itself, add 36. Should be 61. And now we're trying to get rid of this 9, so we're going to divide by 9. And 61 divided by 9 is not going to come out to a perfect number. And so we are just going to leave this. The 9's cancel, and my final answer is just 61 over 9. More practice just with our skills. So we're going to solve the proportion, cross multiply, and we're going to solve this for c. So we're going to get c by itself once we have cross multiplied. So first of all, we're going to get 2c this way. That's going to equal this one, which is 3b. And if we're going to solve for c, then this 2 needs to go away. So we're dividing by 2 since they are being multiplied. That gets rid of multiplication. And you can't do anything over here. It is fully simplified. And our final answer is just 3b over 2. Okay, cross multiply here, either direction. So when we go here, it's 4x times m. Those are just going to all go together. So 4xm equals 3w. And we are solving for w, so we are going to go ahead and divide by 3 to get w by itself, which we've now done. And our final answer, we can't do any extra simplifying here, is just 4xm over 3. Again, cross multiply, we're solving this one for a. This direction we get a y. This way we get bx. Traditionally, you're going to put those in alphabetical order, but not super important. And so we're solving for a. We want to get a by itself, so this y needs to go. They're being multiplied, so we're dividing by y. So a equals bx over y. Okay, 16. Let's go ahead and start setting these up now, setting up a word problem and solving it. So baseball team plays 2 innings in 25 minutes. That's your initial rate. 2 innings take 25 minutes. And if they're going to play at that same rate, they're not going to get faster, they're not going to get slower. It's just going to be an extended amount of time. Then we can set it equal over here. So at this rate, meaning we're not changing the speed of the game, they're going to keep going at that rate. How many minutes will a 9-inning game take? So notice, again, I wrote out the units. I think that's really important in making this simple. The top is innings, the bottom is minutes. We're just comparing these rates. So if 2 innings take 25 minutes, how many minutes will 9 innings take? So you just kind of look, what's the other information they've given me? It's innings, so I'm going to line it up with exactly how I set up my initial rate. And that means I'm trying to find out this, how many minutes will a 9-inning game take? So I'm going to go ahead and cross multiply. So it's 2x equals 25 times 9. So 225. And we're going to divide that by 2. Now that's not going to come out to a perfect number, but it's going to be a nice enough decimal. 225 divided by 2 is 112.5. And we're talking about minutes. So 112.5 minutes is a perfectly acceptable answer. It specifically said how many minutes. So we normally don't talk about like it took 112 minutes, right? We put that into hours and minutes, but this question specifically said minutes. So we don't need to convert this into hours or anything like that. We're good. All right, we did skip 17. We're going to 18. So this place in Hawaii is considered the rainiest place on Earth. In an average week, 9.1 inches of rainfall. If you're on this island for 2 days, how much rain would you expect to fall during your stay? So at initial glance, just quickly glancing at it, it only looks like they've given you 2 numbers. And when we fill in these proportions, we're always given 3, and we're just trying to find the 4th. So we need to be careful. And the 2 numbers that they give us are not even the ones that should be paired together. 9.1 inches is how much rain falls in a week. It's not directly related to how many inches fall in 2 days. So since this is talking about days, this is talking about weeks, we need to make one of them the same unit as the other. Now trying to turn days into weeks, like it's 2 out of 7, it's 2 sevenths, that could be a nasty decimal. We don't need to go down that road because we know 7 days are in a week. So 9.1 inches of rain is over 7 days. That's going to be our initial rate. So 9.1 inches is in 7 days, and that is going to equal this side. Go ahead and set up your units exactly the same, and it makes your life super easy. So now we want to plug days in because that's what they gave us. So if it rains 9.1 inches on average in 7 days, how many inches could you expect for 2 days? Okay, it makes sense. Cross multiply. Divide. And our final answer here, x equals 2.6 inches. Next up was number 20. All right, so we're buying 2 televisions here, 2 different sizes, a smaller and a bigger one. The total cost of the televisions was $4,600. The ratio of prices was 6 to 17. As soon as I see that, I am setting that up. 6 to 17 is going to equal something. Okay, that's the ratio that's important. So obviously the smaller TV is less expensive. So smaller TV would match on this side, bigger TV would match on this side, and we are going directly on cost. The cost of this, if you compared the 2, reduces down to 6 over 17. Okay, so if this one was $6, this is $17. If this was $12, this is $34 because you would just be doubling these numbers. They're going to be in that direct relationship. Now, we got to come up with something over here. All we know is that together they cost $4,600. So you can start on either one, because it doesn't say one is more than another or less than another, an exact amount. Now, obviously, we know the smaller one is less. But we don't know how much less. We just know that together they're $4,600. And we know they're not equal. We're assuming they're not equal. So you can call either one you want X. So I'm just going to go ahead and put X right here. So the smaller television's price, we're going to call X. We have no idea what it is. But what we do know is that if I take X and I add this one on the bottom, I'm going to get $4,600. That's the total cost. So if I now told you that the small one costs $600, you would tell me, well, the other one costs $4,000. So what did you do with that $600 to come up with the $4,000? You subtracted $600 from this, and you end up with your other cost. So once I know what X is, I'm going to subtract it from $4,600 to find the cost of my other one. So how do I express that? $4,600 minus X. So I don't know what this costs, but if I do, and once I do, to find out my price of my other one, I'm going to subtract the price of this television from the total, and that's going to leave me with the price of the other television. Okay, now I'm all set up. Let's go ahead and cross multiply. So we're going to get 17x equals, and then going this way, you got to do 6 times 4,600 minus x. So we're going to need to be careful when we distribute here. This is a negative x. So 17x equals, we're going to do 6 times 4,600. And 6 times negative x is negative 6x. So when I go to get rid of negative 6x, I have to add 6x. So that's now gone. So we have 23x equals this. So I'm going to divide 27,600 by 23. And I get x equals 1,200. All right, now we want the price of both televisions here. So one of them equals 1,200. Based on the fact that this is x, we can glance back to our setup and say, okay, that's the cheaper one. The cheaper one is 1,200. To get the other one, I'm just going to do my 4,600, which is the total cost of the two TVs together, and subtract the cost of the first one. And so that comes out to 3,400. Okay, so double check yourself, add these up, make sure that it comes out to 4,600. It does. We can also check this by putting them in a ratio or a fraction and making sure that when it simplifies, it comes out to what? 6 over 17. So the cost is in a ratio of 6 to 17, and they add up to 4,600. We are good to go. All right, and a couple of review questions now before we get out of here. 22, a raft is a rectangle. It's 8 by 12 feet. It's in a circular pool. Okay, so we got a big pool. It's a circle. There's a raft inside of it. That is 8 by 12. And they tell you the circular pool is 40 feet in diameter. So you got to be really careful with circles because they either give you the radius or they give you the diameter. So all the way across is 40. That's the diameter. When we go to solve for area of a circle, area is pi r squared. We need the radius. So you cannot plug 40 in. It's a big mistake people will make. They'll just grab whatever number they see and start plugging it in. 40 is all the way across, which means it's split into 20 and 20 from the center out each direction. That's the radius. So when we do go to find the area of the circle, which we're going to have to, 20 is the radius that we're plugging in. So we're going to also need the area of this, because what they're going to ask us here is, if a watch is at the bottom of the pool, what's the probability? So probability, we're going to compare our favorable outcomes to the total outcomes. Flipping a coin and getting heads. The favorable outcome is heads. The total outcomes is 2. So it's 1 to 2. Rolling a dice, trying to get a 5. Favorable outcomes, there's only one way to get a 5 out of a total of 6. So that's how you do your probability, favorable outcomes over total outcomes. When we're talking about this, the favorable outcome is that it's directly underneath this raft, and the total outcomes is it's anywhere else or anywhere in the pool. Okay, so we need to compare the area of the raft and how much of that raft is covering this. If the raft was exactly the same size as the pool, think about it like that, covered the entire pool perfectly, okay, what is the probability that it's underneath of it? 100%, because the favorable outcomes is the same as the total outcomes. Now we're making this smaller. There's a chance that it's somewhere else. So how much of the total outcomes is covered by the raft? So 8 by 12. Go ahead and multiply. So area is base times height. We're talking about a rectangle. That's 96. So I'm going to already come down here. My favorable outcomes here is 96. What's the chance that it's underneath that raft? So the area of the raft is 96. Okay, my total outcomes is the total area of the pool. Could be anywhere in the pool, including under the raft. So we're not subtracting that out or anything. The total outcomes includes everything under the raft and also not under the raft. So I need to go ahead and plug in here. Radius, again, is 20. So we're going to do 20 squared, which is 400. And we cannot forget about pi. Because remember, pi is not just like some random thing that tags along. It's not centimeters or feet or anything like that. That's just there to identify what the unit is. Pi is a number. So when I say 400 pi, I'm actually saying 400 times 3.14 on that whole number. Okay, so this is not just 400. This is actually 400 times 3 point something. So 400 times pi. Now here's your pi button in blue right above this. So you hit second, hit this. If I actually multiplied it out, this number of 400 pi, the area of that pool, is actually not 400, it's 1256 and then some change there. Okay, so that shows you how important pi is. The number 400 and the number 1256 are not even close. Okay, so we cannot just call it 400. It's 400 pi. Now when I set this up, I don't want this nasty decimal. Okay, because I'm going to have to round it at some point here, and I don't want to do that. So I'm going to just call the area of the pool 400 pi. What's nice about that is my calculator will handle that for me. So when I go ahead now and divide to find my probability or my percentage, I can just punch in 400 pi. I don't have to type in a decimal that's close to it because I rounded it. So all I'm going to do now is 96 divided by 400. And I need the pi. If you just do 96 divided by 400, it's incorrect. So get that pi in there. 96 divided by 400 pi looks like this. And actually, if you check your answer key, that is not correct. So let's talk about why it's not correct. If I hit 96 divided by, and then I go ahead and I put this, start over, 96 divided by 400 in parentheses, pi, I get that answer, and the one that I erased there a second ago, I didn't use parentheses, and I get a different answer. So we need to, one, understand why we're getting a different answer, and be smart enough to do it the correct way. If you do not use parentheses, that means that you're telling the calculator to follow the order of operations that they see. I have two things going on. I have division and I have multiplication, and if I don't tell the calculator otherwise, it's actually going to divide first, and then it's going to times. And that's a problem. We don't want it to do that. We actually need it to times first and divide by that whole quantity. Okay, the order does matter with division. If it was all multiplication, it's never going to matter. But because there's division, the order in division always is going to matter. And you can clearly see that here. We're getting different answers. Okay, so the correct one, when you plug this in your calculator, is to use parentheses so the calculator knows it's 96 divided by this whole quantity, the number you get when you multiply 400 times pi. So this is our answer. This should just make sense. I mean, not make sense anyway. If you called this 75%, just kind of, if you drew a picture, there's no way that this is covering 75% of the pool, right? This is a small amount. So that should throw up some red flags automatically when you get that number. And so when I look at this, I'm going to move it 2 spots. It's about 7%, 7.6 is as far as I'm going to go. The 3 is going to leave it a 6. So we are going to say about 7.6%. All right, that was 22. And the last one here is 23. Another probability question. So we've got a bowl. It's got different color beads in it. I'm going to need the total, so let's go ahead and just do that right now. So I'm adding up the 8 green, 4 red, 11 blue, and 6 black. There's a total of 29, so let me go ahead and write that down. So out of those 29 beads, find the probability of choosing a red. So again, favorable outcomes over total. So the total is 29. It's something out of 29 when you reach in. There's 4 red beads, so you have a 4 out of 29 chance. Part B, find the probability of choosing a black or a blue bead. Each one of these is assuming you're starting from scratch. You didn't take out that red one and not put it back. We're starting over. All the red are still in there. So our total is still 29. Chances of pulling a black or a blue, you got to add them together. So there's 6 black and there's 11 blue. So it's 17 out of 29. The last one, find the probability of choosing a bead that is not green. So we need to add up all the ones that are not green. Or you could go ahead and you could just take the 8 green away from 29. Or you do 6 plus 11 is 17, plus 4 is 21. Or you take the 8 away from 29. Either way, there are 21 beads that are not green out of 29. So your probability is 21 out of 29.